This is Robert Kudarian, and today we're going to start with a dad joke. After a week of stringing you along, we're going to move on to Booleans, if and while, and we're going to learn how to alter our program flow. So from what we've seen so far, is we have a program, and it runs the first line of code, and then it's going to run the second line of code, it's going to run the third line of code, and then finally it's going to run the fourth line of code. Print. I don't know. 1 plus 2 plus 3. Doesn't really matter. So far we've seen it runs from top to bottom. And that has worked out very well for us and is still true. Our programs still run in sequential order, but we can use if statements and loops to skip lines of code or repeat lines of code. And still those blocks will be run in order. But we will alter the flow. And that's very important to us because they're important. Think about logging into a website. If your username and your password don't match what is on file, what should it do? Should it let you into the website? No. So we're going to use something called an if statement to say, if these match, you're allowed into the website. If these don't match, no, you're not allowed here. And different code will run based on different inputs. And that is really the essence of interactive computing. Like running a program like this from top to bottom, and you could do a lab inside of Python and recalculate whatever you're calculating for this lab using very advanced equations and setting variables, and boom, you'll get a result in fractions of seconds, which is super cool. But does that work for video games? Not really. Video games are based on input, like Word document, based on input. It's these things that we're starting to move into versus just straight rote computation. So, what is truth? I really love this slide. For our use, it's literally the word true. Capital T-R-U-E. Capital T. Very important. True is true, and guess what false is? False is false. And these are called Booleans. They're Boolean variables, true and false, 1 and 0. This is where computer engineering and computer science start to hand off. Computer engineers will build a system and a processor and all of the circuitry to run things, and they will talk in volts of 0.5 and 0. Computer science will see that 0.5 and say, that sure looks like a 1 to me, and a 0 as 0 volts as a 0. And that can map to true and false. And with that, we have binary, and from binary, we can build incredible things. So that is where part of the Venn diagram of where we exist is. Woo! So conditional statements will return us some Boolean values, true and false. So this lecture is somewhat abstract in the fact that we're just seeing what is true and how to calculate true and false. And then next class we'll get into if and using these conditionals. So how do we create these in code? How do we do comparisons? Well, we have something called equality, and that is using 2 equal signs. So 1 equal sign is assignment, 2 equal signs is equality. That's very important. So in terms of code, you have a bunch of assignments. One right side is equal to the variable 1 left side. So we've seen this. What the right-hand side gets calculated and gets assigned to the left-hand side. Great. But what if we want to do more? So I'm going to say print is 1 equal to 2. And you can read that as equal to. So you'll see throughout the term that I really speak through code. And is 1 equal to 2? No. No, it's not. So we'll get back false. And we could say is 1, we'll do the interactive console, 1 equal to 1? Yeah. 1 equal to 2? No. And we're asking the computer questions. And at this part, it seems really abstract and kind of silly. But imagine one of these as a variable that somebody's using with input. Is input of what is your name equal to Rob? Well, then you must be Rob. Come on in. So just kind of remember that these are just variables and that they can get set by user input. So equals 2. two equal signs, two equal signs, two equal signs. Conditionals. What about if we want to see if something is not equal? Well, we'll bring in the exclamation mark. Very exciting. Is 1 not equal to 2? Well, yeah, 1 is not equal to 2. That's true. That is a true statement. Is 1 not equal to 1? Well, that's false. 1 is equal to 1, so it can't be not equal to 1. We can do this with strings too. Is Rob not equal to Franklin? Yeah, definitely not. They're not the same. They're very different. So that is what we're looking at for if we want to see if something is not equal. We will use that more in loops than anything else. And you could obviously, well, we don't know about not yet. There's other ways to do it. Inequalities. Greater than or less than. And again, asking the computer a question. So is 3 greater than 4? Well, yeah. Is 4 greater than 4? No. So this is strictly greater than. I believe the next slide is greater than or equal to. Guess what? Then it does include 4. Is 4 greater than or equal to 4.0? Okay, yeah, good. I haven't tried that. A lot of things that you can just still try. And guess what? Less than and greater than both work. No shock. And both of them you can add the equal sign to say less than or equal to versus just strictly less than or greater than. Cool. Great. Love it. Sometimes you want to invert your Boolean. What is not true? False. False is not true. Is false equal to false? Yeah. There's like interesting logic issues you can solve here. What's not false? Well, that must be true. Is not 1 equal to 1? Well, what did I just do here? I asked, is 1 equal to 1? That's true. And then I flipped it by saying not. So not will take the complement of whatever the current Boolean is set to. So nots will, or trues will become false, falses will become trues. Try it all out in the interactive console and see what you can play with. So that's all interesting. But we want to compound these things because generally just one statement won't satisfy us. Generally, we'll have multiple statements that must be true or false or a mix of the two to see if something is true or false. So or is one or the other must be true. So I'm going to say x is equal to, age is equal to 18. So I'm going to say age is equal to, is greater than or equal to, okay, yeah, here we go. Parental consent is equal to false. True, true, false, true. All right, so, oh boy, do people still rent videos? When I was your age, we used to go to the movie store and rent a video. That might be totally lost on you these days. Or this is true for having an alcoholic beverage at a restaurant. You must be 18 years old or be with your parents and they say it's fine. So it would really say age is greater than or equal to 18 or you have parental consent. There we go. You can actually, there we go. So there you go. One of those things has to be true. So if my parental consent turns to false, then, well, I'm still 18, so I'm still allowed to drink. If I'm now 15 years old and still have a beard somehow, no, it's not going to work. But if you're 15 and have parental consent, true, then that's fine. So you can have compound statements. One of them has to be true, and then the whole thing is true. Then in terms of, you can see that just the word or, which is nice. We'll get to that one in a second. And both of them have to be true. So we have the case of I didn't think of something. Oh, this is terrible. You're with your parents and you're very obedient. So you might be over 18, but your parents are paying. So you want to ask, hey, can I have a beer? Both of them have to be true. So in this case, parental consent is true, but we are 15 years old. So this is still not happening because 15 is not greater than 18. So that is false. So it's false and true, which results in false. But if we're age is equal to 19, so we're definitely greater than 18, and we do have parental consent, then we can do it. And I can change my parental consent here to false, which is actually pretty cool. And then I will fail this and statement. So I have 2 slides. Or is plus question mark? Some people jam on this, and this is called the truth table. If you don't jam on this, that's fine. You still have to understand or. So we have X, we have Y, and we have the result. So we want to have all the permutations of X and Y. So we have X is true, or let's start with false. X is false, Y is false. X is false, Y is true. X is true, Y is false. And they're both true. So this is going to be or result and then the and result. So or false and false is still false. So one of these has to be true for or one of them is true. One of these has to be true for or, so this is true. Both these are true, only one has to be true, so that one's true. And they both have to be true. This is the only case where they're both true. So then we'll have true, false, 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 false. True. I was on a roll. So those are the truth tables. There's a few ways to draw them. So considering that, now let's do this again with numbers. We have X, we have Y, we have or, we have and, or which is plus, and, which is multiplication. 0, 0, 0, 1, 1, 0, 1, 1. It's binary counting. Let's talk about binary. 0 plus 0 is what? I can do this. 0. 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 in binary, in this case, is going to be 1. Now you can see that these two tables are actually the same. And the same is true for and. 0 times 0 is 0. 0 times 1 is, well, multiplied by 0 is 0. And 0 times 1. 1 times 0 is still 0. 1 times 1 is actually certainly 1. Hey. These two are the same too. And the cool thing is the order of operations is the same too. It's ands, that's supposed to be a star, then ors. It's multiplication, then addition. So there is lots of similarities between the two ideas. So that's fairly compelling. We can add brackets as much as we want. Those work too. And guess what? Brackets get priority over all other things. This is BEDMAS all over again, except we have brackets, multiplication, addition, and that's it. So BMA. I'm hoping that's not a dirty acronym for something. Cool. One thing about Booleans is that's really beautiful to name them is something. If you look back at the string methods, you're going to see is, digit, is, ASCII, is something else. There's a whole bunch of different is questions, and those all return Booleans. So it's a bit of a beautiful thing that we can have all of these variables sound very question-y and will return a Boolean towards you, which is super duper cool. Okay, we've seen all these conditionals. You might have to stop and revisit some of them, but now we want to modify our program execution. We want to change which code runs. And this is using the if statement. And this gives us a new piece of syntax. And I'll make this joke a few times in this course. there's always new syntax. Whatever we add, there's always new syntax. And that is the code paragraph. So you can see here that this print welcome is indented. Oh, okay. So this if statement will run all of the stuff that's in this indented block of code. So I'm going to say name is equal to input. I told you I'd do it. I will actually show you my code. Oh, you didn't even know. What is your name? Question mark, space. Little prompty thing. And then if name is equal to Rob, print. You guys don't know me well enough for me to be really self-deprecating. You talk too fast. Which actually, apparently in videos I don't. And I can also have more stuff. Print more stuff. As long as it stays in the code paragraph, all of it will run. Then once we close our code paragraph, print, that will run either way. So what happens here is that we ask a question. We don't need braces. You'll see that in my slides. I don't actually have it in this one, but that's okay. I often put brackets around it. That is optional. And if you think about order of operations, it'll just resolve the brackets, which does nothing. And it's the same thing. I think it looks pretty. Well, Java requires it. So if you're planning on taking 1020, you might as well just start doing it to practice. Some people think this looks pretty. I can't disagree, but you don't agree. So if I run this, it's going to print out all the stuff first and then say, what is your name? I'm going to say Bob. And then the thing that ran either way will run because we asked the question, is the name equal to Rob? And this was false. If it's false, the if statement does not run. Everything in the code paragraph gets skipped. Then it'll skip down to here because it skipped that code paragraph and run that either way. Now, if I do give my appropriate name, it'll print out all this stuff in the code paragraph that's in the if statement, and then still continue running. And in this case, it just ran top to bottom exactly how we would expect, and then be done running. So that is your first if statement. The rest of this week is talking more about if statements and additions to our if statements and if else and else ifs and whiles, which is a repeated if statement. So if your dog does a poo, put it in the litter bin. I hope you're having a good day. I'll talk to you later.